Hello, good evening everybody. My name is Vishwadeep and I welcome you all on Unacademy's Computer Science Channel for unlimited learning. In this particular session, I'm going to talk about queue, very specific queues like priority queue and double-ended queue. In double-ended queue, we will check out more type of double-ended queues like input restricted, output restricted, and in priority queues, I am going to talk about how priority queues can be implemented and how those implementations will affect the complexity of their implementation. So without delay, let's get started. So before I proceed further, I want to introduce myself for those members who don't know me. My name is Vishwadeep, written GATE multiple times in the computer science. Third year in engineering 682, final year 19 rank, after that 119, 440, and there are few more ranks I am having under my belt. This is the profile you can see. Masters from IISc Bangalore, another masters Bits Pilani say in the data science. Overall 13 years of experience to train only engineers. 9 years I am having in the GATE and EAC domain. These are the courses right now I am teaching on Unacademy's platform. Yes, this coding interview problems I am teaching weekend to weekend, Saturday and Sunday, 11:30 a.m. on the same channel. You can come live and you can learn these topics also. I am going to solve tomorrow few more questions of coding interview on the chapters link list and further more topics. Fine. If you want to learn for free, you can come on Unacademy's platform and follow my profile over there. Tomorrow I am going to have a special revision session for pipeline topic, 8:30 a.m. Yes, 8:30 a.m. to 11 a.m. 2.5 hours. Entire pipeline revision is done with the question, with the topic, concept and everything. Marathon session 2.5 hours tomorrow. Let's meet on Unacademy's platform. Okay, apart from that, this is the test series we started. That's for free. You can go and you can check it out. आपको free में test मिलेंगे and you will be learning a lot from different so many good questions. Apart from that, look at this. This is the complete package we are providing here for free for all of you. You go and check out other courses which we have conducted, which we are conducting on this particular very channel. Okay, now the main point of the preparation is you should get the output of your preparation. If you are getting good marks in your test, well and good. If you are getting satisfied result from your preparation, well and good. If not, then take the help of Unacademy Plus. That particular help will be in that situation, in that condition that you will be definitely benefited out of this kind of work which we are providing on Unacademy's platform. What we are providing: live classes, we are providing crash course batches, we are providing test practice questions, we are providing doubt solving and lots of such things which can boost your marks, which can boost your satisfaction level, which can boost your preparation level to something another level, which can definitely change your perspective about learning, which can definitely change your own way about learning. And for that, if you want to take Unacademy Plus subscription, that is available with discount if you use the code VDEEP10. इससे आपको डिस्काउंट मिलेगा, इससे मिलेगा आपको मेरा mentorship, and you will get more other benefits if you use the code VDEEP10 for your discount and subscription. Subscription of course will have a lot of impact on your learning and your end result. If you are really interested in reaching to the higher end colleges, then come on Unacademy Plus और आपको मिलेगा बहुत 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 कुछ. If you are the person who need a personal coach, who can't rectify every single problem by yourself, then you should go for Iconic subscription. This Iconic subscription contains all the facility of Unacademy Plus, plus extra a personal coach facility. That fellow will provide you study planner, will give you some study booster sessions, will give you personalized test analysis so that you can understand ki how you need to solve the questions in the next test, how you can rectify your problems of not getting good marks. If you want such kind of things, if you want preparation strategy material and study materials, then all those things come under Iconic subscription, and that Iconic subscription is again on on the discount if you use the code VDeep10. कोड याद रखें VDeep10, यही कोड यूज करना है और उससे आपको मिलेगा बहुत 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 सारा फायदा. Okay, okay, fine. Then let's get started and let's start the session for the day. But as always, as usual ritual, I want to ask a simple question from you. Are you ready, my friend? If you are ready, I want your energy, I want your excitement of learning so that together me and you can have a good environment of learning. I want from your end one more thing, that is, please share this particular session with all of your friends so that they also can join the session live, just because today you are going to learn lots of things which you might have not heard before. तो वो सारी चीजें सीखने के लिए आपको लाइव आना पड़ेगा और आपको कंसंट्रेशन के साथ में, with concentration you need to learn a lot, you need to be consistent. So let's get ready. Till now what we have seen in the Q and other things. Okay, so in the Q chapter, in the last class, I have already explained you what is a linear queue and circular queue. As linear queue, you know that linear queue does not use your data structures space properly, your arrays properly. Hence, we are going for circular queue, which can efficiently utilize the space. Then NQDQ algorithms I have explained you. Then array and linked list implementations I have explained you. Now today what we are going to see is some of the questions which we have left yesterday, some other functions of queue, and then we will switch to the double-ended queue and we will switch to the priority queue. Okay, 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 yes, of course. अरे कैसी बात कर दी. ये रहो गेट के क्वेश्चंस, ये रहे हमारे पास. Whichever gate question are required for your classroom training, those gate questions also I will bring in the classroom and I will solve it. And if you want more gate questions, like sir, all the gate questions we want, then you do one thing, you go on to this particular link. Go to this link, tiny.cc/vdeep10. इस लिंक पे जाओ, you will get a Notion page, one particular kind of a web page. On that page, you will be getting the data structure section. In that data structure, go to the PYQ. I have taken so many special classes on Unacademy platform. There I have solved the questions of stack, queue, BST, binary tree, regular tree, and hashing. All the questions I have solved of the gate previous years. सारे सॉल्व कर रखे हैं डिटेल्ड मैनर में. गो एंड चेक इट आउट. इफ यू आर स्टक एट समवेयर, ask me the doubts. But I have already taken and few more sessions I'll be taking definitely on the YouTube also. Okay, let's go further. What are the other functions we have in the queue? We will start with this one. Is empty queue. Another function we can implement in the queue is this one, is empty queue. Is empty queue will return you value either true or false. क्या return करेगा आपको? Either true or false. Now when it will return true, is empty queue yes, yes, true, yes means this particular true will be returned when queue is empty. When the queue is empty, and it will return you false otherwise. तो ये फंक्शन आपको कब रिटर्न करेगा? ट्रू, व्हेन द क्यू इज एम्प्टी. एट दैट टाइम इट विल रिटर्न यू ट्रू वैल्यू. फाइन. ओके, any specific question or any specific topic you have that sir these PYQs are tough for us, you can tell me, you can let me know, you can send me messages about, so that I can conduct those sessions on the YouTube also. Though I have already recorded on Unacademy's platform, but still I can do those here also in the live mode. Don't worry about it. Okay, Q front and Q rear. What Q front says? Q front says that it returns the front element. It returns the front element of the queue. Front element of the queue it returns the front element of the queue, but without changing the queue. Without changing the queue. मतलब क्या है इसका meaning is this कि in the queue suppose you have the queue like this way. Q U E U E. Q is like this way: 1, 8, 5, 9, and 16. These are the elements. This is the front element. This is the rear element. So this Q front, what it will return? It returns the front element 1, and the queue will remain as it is. No any deletion happens, no any changes happen in the queue. The element should be same to same, from front to rear same to same, no any changes, but it returns only the front element for my reading purpose. अगर ये समझ में आया है तो क्यू रियर क्या करेगा? इट रिटर्न्स व्हाट? इट रिटर्न्स, बोलो रे बोलो, द rear element. But because of rear element I can read or I can check it out from the queue, then will it change my queue? No, without changing the queue. Without changing the queue. Is that cool, clear, understood everybody? सबको समझ में आया क्या? If that is clear, then we will go further. Queue front, queue rear. So in this above queue, in this particular above queue example, if I will check out this function q rear in this particular queue, what it returns? What it returns in the above queue? It returns the last element, rear element 16, and the queue will remain as it is. ठीक है? Very good morning everybody. Whoever joined later, very good morning. Welcome. Okay, yes. Okay, there is a question, sir. CPU uses queue for scheduling. Yes, there is a ready queue, right? That particular ready queue you can maintain. But if you are using first in, first out algorithm or FCFS algorithm, first come first serve, in that case only the queue ka regular implementation works in operating system. If you are talking about the priority based scheduling or something else based scheduling, in that case you need to go for the priority queue, not the regular queue. I will tell you ki what priority queue is, थोड़ी देर में पता चलेगा. Okay, fine. Let's go further. A circularly linked list is used to represent a queue. Okay, so there is a circular linked list singly. It is representing a queue. A single variable p. So only single variable we have p. It is used to access the queue. So only single variable I am using to access the queue. To which node should p point such that both operations nq and dq can be performed in constant time. तो किस node को ये p point करे so that nq and dq can be performed in constant time. Now you should know कि nq is done at the rear end, means at the end you need to insert, and dq is done from the front end. अगर delete करना है तो ये element delete करना है. Insertion will be done after this particular node. So if suppose I will take option B, front point. So if P is pointing to here and I want to insert a new node will be inserted at the end here after this rear node, this way. So rear ka next should be this one and this ka next should be front. I can get address of this, yes. So new nodes next P, fine, no problem. Do I know the address of the rear node right now? No. Can I get it directly from the P? No, nahi kar sakte. Why? Just because to reach to the rear node, to get the address of this, I need to go sequentially with the traversing. इसका मतलब है कि front node को point करने से काम नहीं चलेगा. Answer incorrect. Second, next option is this node next to front. P is pointing to here. If P is pointing here, in the same case, that's again the same thing happens. Node next to front, this one. If P is pointing to this one, new node I'll have to insert at the end. अभी वापस बताओ कि how we can have insertion. No, insertion cannot be done in constant time. Why? Just because if I will have to change rear का next is equal to this new node, I don't know address of this particular node right now. Why? Just because we are using only single variable. दे रखा है क्वेश्चन में. Got it, got it. So this is also gone. Let's try for rear node. If rear node also cannot give us the answer, then we will go for C option कि not possible with a single pointer. चलिए तो इसको P को ले लेते हैं यहाँ पे. If P is pointing to rear node, can I insert this particular new node in constant time? Yes, I can do it. How? Here element I can copy which I'll have to insert. Fine. Here what should I copy? Here I should copy the address of this node, and that I can access using pika next circularly this particular node, like this way it is. Pika next is equal to this node. Yes, so pika next I can copy here, means that's done. And now pika next I'll have to change by this new node. Yes, done, which means insertion can be done in constant time. There is no any traversal required. Now second thing I need to know here, deletion. How will I delete this particular front node? Rear pointed by P, its next is equal to pika next connects. So I'll write this one ki pika link or pika next is equal to p's next, and your work is done. Your work is done. Deletion of the front node is done, which means you can perform NQ and DQ both in constant time. If P points to the rear node, answer A is correct. Answer A is correct. Good, 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 good. गुड नाइस अमेजिंग. चलिए आगे बढ़ते हैं. अगला क्वेश्चन है, दिस वाज हैविंग अ स्मॉल ट्रिक. दिस पर्टिकुलर क्वेश्चन वाज वेरी वेरी इजी बट हैविंग अ स्मॉल ट्रिक. इफ यू मिस इट यू आर गॉन. इफ यू डोंट मिस इट यू विल गेट 1 मार्क्स. 2018 का क्वेश्चन पेपर है. इन दिस पेपर ओनली आई स्कोर्ड 440 रैंक without any preparation, and you know why? Only one thing is you need to know ki how to solve the questions. You need to concentrate on understanding the question. Never try to reach to the solution. Solution will automatically come. Question automatically screams always कि मालिक ऐसे solve करना है इस question को. So once you read a question, try to understand each and every single line and each and every single term. Automatically your knowledge will be used to solve the question always. चलिए बढ़ते हैं आगे, solve करते हैं. How to solve such question? A queue is implemented using a non-circular singly linked list. Fine. The queue has a head pointer, this one, and a tail pointer, this one, as shown in the figure. Fine. This particular thing means it's a null here. Okay. Let n denote the number of nodes in the queue. Fine. Let nq and dq be implemented by inserting a new node at the head. So NQ implemented, insertion new node at the head, and DQ be implemented by deletion of a node from the tail. Fine. Further, which of the following is time complexity of most time efficient implementation of NQ DQ respectively for this data structure? Chaliye, let's do this particular thing. I need to perform NQ at inserting at new node at head. Here I'll have to insert the new node. If I'll have to insert the new node here, what changes I'll have to make? Data part updated, constant time. Link part updated by address of head, constant time. Head is equal to this new node, constant time. Means insertion at the starting is done in the constant time. So insertion is done in constant time means first one NQ के लिए constant time. For NQ तो constant time. Let's talk about DQ. What I always do in such questions, right? I don't go with my knowledge or something. I try to do it. मैं कोशिश करता हूँ इसको करने की कि how will I do it? If I will have to perform DQ at the end means from the tail, this node I'll have to delete. If I'll have to delete this particular node, करना क्या है? Let's do it. Let's graphically do it. How and why and what I'll have to do? I'll have to delete this node. Yes. If I will delete this particular node, what changes I'll have to make is the second last node का next should be null. Second last nodes next should be null, and this tail pointer I'll have to update by this second last node. But the problem is, do I know second last node ka address? No. Can I get it from this tail pointer directly? No. अगर ऐसा नहीं है तो फिर क्या होगा? What will happen in that case? How can I reach to the second last node? Starting from head, and I will traverse. In that particular case, deletion's complexity will become theta of n. Why? Just because you are requiring a traversal to reach to the second last node. So deletion of the last node will have the problem. Why? Just because the second last node's address is not known, which means we need to have complexity for insertion constant, but for DQ answer is theta of n. You will go for option B. You'll go for option B. So yes. So what happens? What I have explained previously, ki insertion should be done from the last, deletion should be done from the first. Constant time operation. They have given just reverse of it. They have given reverse of the standard procedure, and because of that time complexity has been changed. हमें क्या लगता है? फ्रंट और लास्ट दोनों दे रखा है, इंसर्शन डिलीशन करना है, आसानी से बन जाएगा. कांस्टेंट लेट्स गो, 1 मार्क मिल गया. But always concentrate on the questions, understand what is the procedure to perform the operation. If you understand that procedure, you will definitely get the correct answer. Directly kabhi bhi solve nahi karna question ko. Remember this point. This was a small tricky question. One more trick they have given, right? एक और छोटी सी ट्रिक देखो उन्होंने दी है. इस डायग्राम में उन्होंने सेकंड लास्ट नोड ही नहीं बनाया. They have not given you second last node. You know what happened with that case? उसकी वजह से होगा क्या पता है? उसकी वजह से you will not actually concentrate on second last node and its updation directly. If you are going for direct option, in that case you may miss this trick. And that has happened. Multiple students have gone with the wrong answer, option A, sir, constant, but which is wrong. Fine. So remember how to solve the questions in GATE exam and how to concentrate. Please try to do that. Now next heading is double-ended queue. With the name itself, it says कि it is performing the operation from both the ends. दोनों end से queue है, which means it's a very simple definition, very specific type of queue. It is insertion and deletion both can be performed from both the ends. Means from rear and front end, both the ends you can perform both the operations. Usually insertion you can do only from the rear end. That is the standard. Standard says insertion from rear, front from deletion from the front, but double-ended queue says insertion both the ends, deletion both the ends. That's a very specific implementation. If you have double-ended queue, in double-ended queue, there are two types. One is input restricted double-ended queue and second one is output restricted double-ended queue. Restricted means restriction on the input or restriction on the output. So input restricted double-ended queue says that we are restricting on the input. Input means insertion. Insertion is restricted to the standard end. Standard end input के लिए क्या है? NQ के लिए what is the standard end? Rear end. And so in this particular input restricted double-ended queue, input only is restricted and that is restricted to its standard end, which is rear end. For output restricted double-ended queue, output is restricted only and that is restricted to its standard end, means फ्रंट एंड. अभी एक सिंपल सा क्वेश्चन मैं आपको बताऊंगा, एक चीज मैं आपको बताऊंगा कि इन द इनपुट रिस्ट्रिक्टेड डबल एंडेड क्यू एनक्यू कैन बी परफॉर्म्ड ओनली फ्रॉम द स्टैंडर्ड एंड विच इज द रियर एंड. यस, सो एनक्यू कैन बी परफॉर्म्ड फ्रॉम ओनली रियर एंड. एंड व्हाट अबाउट डीक्यू? Is there any restriction on output in this particular type of queue? No. So DQ can be performed from both the ends. DQ को दोनों एंड से परफॉर्म कर सकते हैं, बट NQ कैन बी परफॉर्म्ड ओनली फ्रॉम द रियर एंड इन द इनपुट रिस्ट्रिक्टेड. अगर आउटपुट रिस्ट्रिक्टेड है तो आउटपुट इज रिस्ट्रिक्टेड टू द फ्रंट एंड, सो DQ इज पॉसिबल ओनली फ्रॉम द फ्रंट एंड, बट NQ इज परफॉर्म्ड फ्रॉम बोथ द एंड्स. तो दोनों एंड से परफॉर्म हो जाएगा deletion or DQ, oh sorry, NQ in the output restricted, but DQ is performed only from the front end. Simple सा concept है, नाम से समझ में आएगा, you can remember easily. Got it? चलिए अब बात करते हैं प्रायोरिटी क्यू की. व्हाट इज प्रायोरिटी क्यू? डू यू नो व्हाट इज द डेफिनेशन ऑफ प्रायोरिटी क्यू? क्या आप लोगों को पता है प्रायोरिटी क्यू होती क्या है? व्हाट इज द प्रायोरिटी क्यू? डू यू नो? डू यू नो? Do you know? Okay, if you don't know, okay, no problem, I will tell you. I will tell you ki what is the priority queue. Okay, so priority queue is what? Priority queue is this, ki every element in the queue, every element in the queue has associated priority, and always remember, ये point important है, this is very important point, कि always highest priority element is deleted. Highest priority element is deleted from the queue. So you are maintaining a queue and in which every element is having one associated priority, and every time you perform deletion randomly, any element you can't delete, you need to delete that element only which is having highest priority. अब आप बोलोगे सर highest priority का element if not present on the front side, then can I delete from middle? Then for that you need to wait for 5 more minutes, just because I will tell you ki how priority queue is maintained. How the priority queue is maintained, based on that only you can understand ki how deletion happens. But that is for sure ki whenever a deletion happens in the priority queue, then you need to have deletion of the highest priority element. याद रखिएगा, हाईएस्ट प्रायोरिटी एलिमेंट ही डिलीट होता है. अब बात करते हैं आगे. क्या बात करते हैं आगे? आगे ये बात करेंगे, इफ प्रायोरिटी क्यू टू बी इंप्लीमेंटेड, हाउ इट विल बी इंप्लीमेंटेड. यहां पे मेरे पास बहुत अच्छा एग्जांपल है. सी, इफ यू परचेस समथिंग फ्रॉम द मार्केट, राइट, कुछ खरीद के लाए हो, या इफ यू आर कमिंग फ्रॉम योर कॉलेज, ऑफिस, और यू नो ट्यूशंस, और फ्रॉम समवेयर यू आर कमिंग एंड ब्रिंगिंग लॉट्स ऑफ थिंग्स, मे बी स्कूल से आते हो. हैव यू एवर डन दिस पर्टिकुलर थिंग कि यू आर कीपिंग योर शूज ऑन द प्लेस, सॉक्स ऑन द प्लेस, बैग ऑन द प्लेस, कीज ऑन द प्लेस? नो. ये जूता इधर से उड़ाया, ये जूता इधर से उड़ाया, सॉक्स इधर, एक सोफे पे, एक बेडरूम में, एंड देन यू विल कीप द थिंग्स एट रैंडम प्लेसेस. And when it is required element, suppose आपको बाइक का की चाहिए, you need socks, you need shoes, then you will search कि कहाँ है हमारा socks. Understanding? So one is this type of implementation in the priority queue. In this particular implementation which I told, you are not handling the priority at the insertion time. Means जब आप सामान लेके आए, when you have brought the items at home, you are not understanding the critical situation of the priority. You are not thinking about that might possible I will require this element or this particular item later on. No, अभी फेंको. Right now what happens when you require, at that time you are searching ki where the item is, and based on that it is taking time, and then you can go further. So priority queue implementation is having one type. That particular first type is handling the priority at deletion time. Now what is this at deletion time? Means When I want to insert a new element in the queue, I will always insert at the rear end. I will always insert it at the rear end. आखिरी में insertion कर देने का. I don't care about कि what's its priority is. उसकी priority क्या है, मुझे उससे कोई फर्क नहीं पड़ता. Now, if I am handling the priority at deletion time, what will happen in that case? At the time of NQ, at the time of insertion, there is no any problem. I am just inserting it without any thinking blindly at the rear end. When deletion is required, I will search my entire queue and I will find out that element. I will find out that element which is the maximum priority element. I will find out a maximum priority element in my entire queue and I will delete it. I will delete it. Understood? Understood or not? Understood or not? So at deletion time, if I am handling the priority, what does it mean? What does it mean? So if I am asking about NQ operation, NQ operation का मतलब है insertion at rear end. Insertion at rear end. But without any thinking, without any tension, no any problem. Now, if you want to perform DQ operation, in the DQ operation, what should I do? I will have to find out the highest priority element. Kyun highest priority element? Just because it's my standard, it's my requirement that in the priority queue, I will have to delete that element which is having the highest priority. So I am writing this. Search highest priority element and delete it. ये तुमको समझ में आ रहा है कि नहीं? Are you able to understand or not? Can you confirm कि are you understanding or not? If insertion at the rear end we are doing blindly, then for this particular operation option or this particular operation, the complexity required is constant time. But if I want to find out the maximum value, for maximum value finding, I will require theta of n in the array implementation. Theta of n time will be required in the DQ. Why? Just because I am finding the maximum. First finding the maximum, after that I am deleting that element. That's why theta of n time required. Let's go for the next one. Next one is, next type of implementation of priority queue is exactly what your mom does. As soon as your father brings some vegetables or some grocery items or something for the house, she manages all those items immediately. She arranges all those items immediately to their respective places. शुगर आया, शुगर का एक डब्बा है, वहां डाल दिया. समथिंग योर फादर हैज परचेज, मार्केट से लेके आए हैं, सो योर मदर विल अरेंज ऑल दीज आइटम्स on their respective places. So whenever we will require, at that time we will not have to think कि कहाँ मिलेगा. Of course its designated place is there where your mom has placed all these items, so it will be easy for you to pick while the picking up time, while the taking up time. Means when element comes, you are going to, when an element comes into the insertion, you are going to manage your queue. You are going to manage your queue in such a way that highest priority element is on the front of the queue. Highest priority element is present on the front of the queue. So how exactly you are managing the elements? In the decreasing order of the priority. So when insertion happens, you insert the new element based on its priority in such a way that all the elements are arranged into decreasing order of priority. Highest priority element always present on the front. So whenever you perform DQ without thinking, you can DQ, you can delete the first element, front element, and highest priority element will be deleted. So at what time you are handling the priority? At what time you are handling the priority? At what time you are handling the priority is insertion time. Handling priority. At what time? At insertion. Got it? So in this particular case, if I want to perform NQ operation, how I will perform the NQ operation? NQ operation I'll have to perform in such a way ki insert the element based on its priority, based on its priority such that the elements should be arranged in decreasing order of priority. So of course your front element will always have the highest priority element. ओके एंड फॉर DQ, अब DQ करते वक्त आपको सोचना नहीं है, आंख बंद करके यू कैन डिलीट द फ्रंट एलिमेंट. ब्लाइंडली यू कैन डिलीट द फ्रंट एलिमेंट. डायरेक्टली delete front element. Got it? Why? Just because I have arranged the queue in such a way, whenever a new element comes, I'll check out its priorities here. Okay, so it should be arranged based on its priority in the queue, so that always we will maintain the highest priority element at the front, so that at the time of deletion it will not take much time. Let's talk about the complexity. This NQ will take big O of n time and DQ will take constant time. ये कैसे लिख दिया big O of n time? I will explain. Suppose there are elements A, B, C, D and E with the priority. So these are the elements and the priority like this way: 10, 6, 5, 3 and 1. 10 is the highest priority. Larger element, larger priority. Larger value, larger priority. Now in this particular queue, this is the priority queue right now I'm having, and in this particular queue I want to insert a new element X with priority value 7. With priority value 7. What I will do, first I will keep that X here and 7 here. I will check out ki 7 is having higher priority than this one. Yes, so E you can shift here and its priority also will be shifted here. Then we will be having here 7, which is X, right? 7 is greater than 3. Yes, higher priority, so 3 will come here. Then 5 will come here, then 6 will come here, and priority 7 element X will be inserted at this point. So element will be arranged in this level, this manner: A, X, B, C, D, E with the priority 10, 7, 6, 5, 3 and 1. So when you are inserting the element in the already sorted array, आपको पता होगा this is exactly the same method we implement in the insertion sort. तो अगर आपको पता है, if you know कि how an element is inserted, in the priority queue, in the insertion sort, how an element is inserted, that is exactly same method I am going to have for this NQ when I am handling the priority at insertion time. Got it? So big O of n time will be required. Why? Just because might possible my new element is having lowest priority, it will be inserted at the end and will be there only. or it will have highest priority, so it can go up to first level by shifting and shifting. That is why you may have complexity big of n and deletion. This one, if somebody asks you which method is preferable, you can say, sir, this is preferable. Why? Just because my motive is to delete an element, so DQ should not take much more time. Delete an element with highest priority is my motive, so deletion at deletion time क्विकली आई शुड हैव दैट ऑपरेशन डन. इसीलिए ये मेथड जो है ज्यादा प्रायोरिटी या ज्यादा प्रिफरेबल है. इफ यू नो द हीप, अगर आपको हीप पता है, इफ यू नो द हीप, then if you know the heap, then what exactly you are doing? If you know the heap, then that particular heap is following this method only, handling the priority at insertion time. You know heap, suppose max heap. In the max heap, the maximum value of your heap should be on the always root, and without thinking you always delete the root. In the min heap, you maintain the minimum value of entire tree on the root, so that without thinking you can delete that element in the deletion. So आपको याद रखना है एक simple सा case कि heap is also one of the example of priority queue, but that is managed in the special hierarchical type of structure, tree structure. But still that is an example of priority queue, and implementation is this one ki at insertion time we are handling the priority so that we can delete without any thinking the topmost element, the root element. Got it. यहां से एक और बड़ा अच्छा सा क्वेश्चन निकल के आएगा, वो ये है, इंटरव्यू में भी आता है, किसी ने अभी टाइप भी किया है और गेट में भी आ चुका है कि हाउ मेनी क्यूज आर रिक्वायर्ड टू इंप्लीमेंट प्रायोरिटी क्यू. नंबर ऑफ क्यूज रिक्वायर्ड इज इक्वल टू 2. Number of queues required is equal to 2. Why 2? For priority queue. Why 2 queues required? Just because in the single queue you will keep only elements. In the single queue, you will keep only elements. So one particular queue for elements and one particular queue for priority. Keeping the priority. So if suppose an element is present here, its priority will be present here. If element is present here, its priority is present here. If element is present here, priority is present here. Like this way, you can have all the elements in first queue, all their respective priority in the next queue. किसी ने पूछा सर नहीं समझ में आया है, then see, देखिए क्वेश्चन जो मेरा यहाँ पे था कि you have these elements A, B, C, D, E with the priorities 10, 6, 5 and 3 and 1. Now I am inserting an element. Insertion will be done. Insertion अगर करना है and that insertion is of element X with priority 7. So with priority 7 is higher than 1, 3, 6 and 5. All these priorities are lesser than 7, which means I need to insert the new element here. Here means after A, so that my priority order can be maintained. My priority order can be maintained how? Why? When I am inserting X here and this level. So what I will do, I will check the priority here. 1 is less than 7, yes, shift it behind, यहाँ कर दो उसको, element यहाँ आ जाएगा. Then 1 is, then next priority is 3. 3 is lesser than 7, yes, so 3 will come here and its element D will come here. Then 5 is also lesser than 7, yes, so 5 will come here and its element C also come back. Then 6 is lesser than 7, yes, so B will come here and its priority 6 will come here, 7 will come here. As of now, X is here. 10 is lesser than 7, no, so you can place 7 here. You can place 7 and x here. आपकी elements होंगे a, x, b, c, d with the priorities 10, 7, 6, 5, 3. This was the insertion and I could do that. Okay, E also remaining 1. Got it? So at deletion time you are deleting the front element without any thinking. बिना कुछ सोचे समझे हम delete कर देंगे किसको? front element को. And then that will be always the highest priority element. Can you confirm कि आपको ये समझ में आया है? Did you understand that one? इतना समझ में आ गया आप लोगों को? If that much is confirmed, then we will go further. Fine. Okay, so before we go further, I want to tell you one thing. Saturday and Sunday I am going to have 2 sessions for you guys. Saturday 11:30 and again Sunday 11:30 in the morning. Both the sessions will be for the practice questions of your interviews. Yes, basic problems I will pick and I will bring for you guys so that we can solve the questions of interview in these classes. Those are placement batches I am running, placement classes I am running Saturday and Sunday 11:30 a.m. And apart from that, one more thing I will tell you that next 2 days, Monday and Tuesday, after that there will not be any morning class for data structure. So we will meet again on Wednesday. Next Wednesday again we will continue from this queue. There are some questions I am having to solve in the classroom. I will bring those questions for you and then we will start the stack discussion in the next class. Okay, so you remember that particular thing. And always remember that if you have equal priority of 2 elements, यहाँ वापस आते हैं, if you have equal priority of 2 elements, you will always insert the next element later. Means whichever element comes first should be in the front side, whatever element inserted later should come in the later part. So if in this particular queue, if you have another element, suppose y, and that is having higher priority 10 itself, but still I will keep a on the front and y on the next level. Why? Just because Q follows first in first out when the priority is same. अगर same priority हो गई तो follow क्या करना है हमें? First in first out. In that particular case, whichever comes first should be deleted first. So among A and Y, both are having higher priority, A should be deleted first. That is my simple standard explanation for you guys. Okay, always remember that particular thing. And one more thing, in this Gate Express batch we have started, you can learn the topics, this and this. COA already going on 7:15 p.m. You can come live to learn it in a really quick way, just because I am going with really good pace, that I could have finished it, or actually I have finished it up to a certain good level in very few days. So it's like a revision class. You can come and join यार, आपको मजा भी आएगा, सीखने मिलेगा, जल्दी खत्म हो जाएगा, रिविजन का टाइम बच जाएगा आपका, मैं कराऊंगा रिविजन आपका, आपके क्वेश्चन भी लगवाऊंगा, आपका प्रॉब्लम भी सॉल्व करवाएंगे एंड टॉपिक रिवाइज भी करवाएंगे. सो यू कैन कम लाइव 7:15 PM टुडे. वी विल मीट अगेन. ओके, याद रखें आप. और साथ ही साथ ये वाला टेलीग्राम चैनल ज्वाइन कर लो, वाई? जस्ट बिकॉज यहाँ पे आपको मिलेगा सारा PDF. Question is, sir, DS will complete till mid-November. Cannot say that कि mid-November तक खत्म हो जाएगा, just because already we are approaching up to really good amount of classes, but we cannot commit any kind of thing for YouTube classes, just because these are like unstructured classes. Whenever we want we can take break, whenever we want we can take longer classes. Like that way it happens. So there is no any fixed date, but yes, we will try mostly to finish this before Diwali vacation, so that you can have some satisfaction कि yes खत्म हो गया. पर गारंटी नहीं दे सकते बॉस किसी चीज की on YouTube. It's just a free initiative. स्टैंडर्डाइज नहीं करते हैं हम इन सारे लेक्चर्स को कि कितने दिन में कौन सा कोर्स खत्म हो जाना चाहिए. गेट का जो क्रैश कोर्स है उसका हमारा फिक्स है कि इतने दिनों में इतने लेक्चर्स खत्म हो हो जाएंगे, दैट इज फिक्स. दिस इज रेगुलर लेक्चर, तो कुछ आइडिया नहीं है कि कब खत्म होगा और कब नहीं. टू बी कनेक्टेड विद अस ऑन फेसबुक, ये है आपका पेज, जाओ कनेक्ट हो जाओ यार जाके आराम से, और रिकमेंड करो सारे फ्रेंड्स को. ये देखो क्रिएट्रिक्स पेज है फॉर इलेक्ट्रिकल मेंबर्स, मैकेनिकल मेंबर्स, सिविल मेंबर्स, तेलुगु मेंबर्स एंड कंप्यूटर साइंस के लिए कंप्यूटर साइंस चैनल है. आप आओ और आराम से मुझसे कनेक्टेड हो जाओ यार, कनेक्टेड रहो. इफ यू हैवंट लाइक द सेशन, लाइक करो. इफ यू हैवंट सब्सक्राइब द चैनल, सब्सक्राइब करो. And if you haven't turned on the notification, make it turn on so that all the classes notification you can get. Apart from that, share these videos with all of your friends. We need a big team of me and you together, so that that particular team, proudly we all can say कि this particular team is Unacademy Computer Science team, and in that particular team we have all the toppers, all type of toppers we are included in this particular टीम. सो आपको वो टीम बनाने में मेरी मदद करनी है, मैं आपकी मदद करूंगा आपको हर एक प्रॉब्लम सॉल्व करने में, आपका सारा डाउट क्लियर करने में, आपके जितने ज्यादा से ज्यादा हो सके इफेक्टिव लेक्चर लेने में. ठीक है. सो टिल देन अगेन वी विल मीट tomorrow, not tomorrow, yes, tomorrow we will meet definitely for placement batch Saturday and Sunday, and we will meet in the evening 7:15 p.m. for COA. Till then, एक और चीज याद रखें, कल मैं पाइपलाइन का एक मैराथन लेने वाला हूं ऑन द अनअकैडमी स्पेशल क्लासेस फॉर फ्री. 2.5 hour entire pipeline done. So you need to just attend that session 2.5 hour, 8:30 in the morning tomorrow. 8:30 in the morning से लेके 11 बजे तक 11 AM तक हम पढ़ेंगे पाइपलाइन. 2.5 hour में पूरा पाइपलाइन डन. ओके, सो लेट्स मीट tomorrow. Let's meet today evening. Till then, happy learning. Have a nice day.